Bonjour, donc moi c'est Maël. Juste une petite question avant qu'on commence vraiment. Qui est ici qui utilise Yarn? Oui, ok, ça fait quand même un petit paquet. Cool. Alors, donc d'abord, qui est-ce que... who am I? Yeah, I will make the talk in English, since from what I understood, there are more people that speak English here. So my name is Maël. I used to work for the past 2.5 years at Facebook as part of the JavaScript Foundation team, and now I work in a similar position at Datadog. My job in both of those companies is to maintain the JavaScript infrastructure used by our engineers, and as part of this, I came to contribute to Yarn. As the time passed, I started to take more and more responsibilities on the project, and here I am today talking to you about what is Yawn, what are our hidden features, and more interesting, what we have been doing for the V2, which is in no small part based on my observations after using Yawn at a large scale for a few years. So the first question that we will have is, what do we mean when we say JavaScript infrastructure? Because we all know what is DevOps for a system, an OS, but what does it mean for JavaScript? The idea is that all JavaScript engineers write code, and mostly product code. We all try to make new features and to do it fast, to iterate fast. But in order to do this, we sometimes have to fight a bit against JavaScript in order to configure our tools. The JavaScript is a wonderful ecosystem with a lot of different tools that can be configured in various ways, but sometimes it becomes a job by itself to maintain all this. So the infrastructure is how to move all the concern of maintaining this infra to a specific team whose role will be to know everything about it. A good infrastructure by itself must be fast, so that product engineers don't have to spend their time using it. It must be transparent, so that ideally they don't even have to know about it. It just has to work. It has to be flexible, so that you can adapt it to different systems as the requirements change. And it must be stable and determinist, so that you can be sure and trust your infra that your application will continue to work in the future as well as it currently does now. That's not always easy to achieve on all of those goals. So first, speaking a bit about Yawn, why was Yawn born? It came a bit because of the points that I mentioned before in terms of infrastructure. There was multiple companies, Facebook, but also Google and Expo, who figured that something was missing. There was a missing piece that was allowing them to write JavaScript product in an efficient way. They figured that the existing solution didn't meet all their needs in terms of stability, performance, user experience, and so they decided to try something new, something with different set of trade-offs. Different architectural choice, but that would still be compatible with the ecosystem at large. So that's why we created Yawn. That was a huge bet, and over the time, I think we managed to prove that we could do it. And since then, we kept this philosophy of always trying to find new solutions to existing problems. And I think of Yawn today as a kind of laboratory in that we try new things, we try to experiment. We don't really stay on the same feature set and say, okay, if you walk around, it will work. We try to really find the right solution to the right problems. So now, how can Yawn help you to answer the needs I mentioned? First, we will talk a bit about one type of development you might have heard before, which are monorepos. About a year ago, 2 years ago actually, we implemented the workspaces. The workspaces originated from the open source community in the Lerna project, and they were used by big projects in the open source, in particular Jest, but also Babel. And they are very interesting because they were a new way to split a project into various sub-pieces. So we decided to do something in order to support this use case inside Yawn itself. And the result is that now you can have real workspaces in Yawn. It means that where before you had one package.json that was listing all of your dependencies, you now can have as many as you want, meaning that you can split your dependencies and configuration and projects apart while they're still able to cross-reference each other and use the most up-to-date code. That has multiple benefits. So separation of concern, as I mentioned, so that your front-end code doesn't merge with the back-end code. It also encourages your developers to use to follow a modular development approach, because then if they need to, for example, use utilities in common, they need to put it inside a shared library. I mean, they should put it inside a shared library. It also makes it easier for you to publish releases, which is particularly important if you have a monorepo that contains libraries that you want to open source. Because then you will want to push one set of your library without having to risk to be desynced between your local application and your library. And yeah, that's. So how to use workspaces in practice? It's very simple. You just have to add a new field inside one of your package.json at the root. And after that, Yann will automatically pick all of the folder that contain a package.json inside the glob pattern and automatically link them together. So there's very few boilerplate in order to make it work. Another feature that we developed and is still quite new is plug and play. So plug and play was created about a year ago. And the idea is that it's a shared... So before you had the non-modules directory that was containing 20,000 files. And that was nice, but that was not super optimized. So we decided to try something, again, something new, something different that would still be compatible with the ecosystem, Yann style. And we came up with plug and play. Plug and play, the idea is that instead of copying the files from the Yann cache inside the non-modules directory, what if we were able to directly say to Node, OK, if you are loading package X, you need to load the files from this location. Since Yann has a full knowledge of the dependency tree, it makes sense that it is HIT that is in charge of telling Node where to find the packages. So we implemented we made a first implementation in Yann 1 that is hidden behind the --PNP flag. And starting from Yann 2, and for a reason that I'm going to highlight later, it actually becomes a default. So starting from Yann 2, there will be no non-modules by default inside your projects. The offline mirror is another feature that is quite interesting and not a lot of people are aware of it. So at Facebook, we noticed something that was very important, was that we didn't want to rely on the NPM registry. We didn't want our deployments to crash because the NPM registry was down or for any other reason. Sometimes it might be just because our network configuration is misconfigured. So sometimes it might be something else. But the main reason is that we didn't want to rely on the network. So in order to solve this, we came up with the offline mirror. The concept is very simple. Each time Yann makes a request to a package on the NPM registry, it stores the answer inside the repository. If you commit this folder, the next time you run Yann install, even if you don't have non-modules and not have a Yann cache, Yann will not make a request to the NPM registry. Instead, it will reuse the archives that have been stored as TGZ inside the offline mirror. It's super useful because you don't have to fetch them from a remote location, which is faster and much more stable. In fact, at Facebook, we barely noticed when the NPM registry was down, and the only reason we even learned about it was because people were pinging us on Twitter to tell us that the Yann registry was down. There is no Yann registry. Another feature that is also not super known, but it's more recent. I think we added it maybe 8 months ago, is Yann policies set-version. The idea is that when you run this command, Yann will add a specific settings within your local .yarn.sc file that contains the second line that you can see with yarn-path. and the path to a file. When the global yarn boots and detects that there is this setting inside the yarn.sc file, it will shell out to the version of yarn that is checked in within your repository. It's super useful because it means that, let's say that you want to upgrade yarn. As long as you have any version of yarn inside your global environment, you just have to make a peer on your project to upgrade it to a different version. And in order for your colleagues to use it, they just have to rebase. They don't have to. They don't have to be careful about the version of yarn that they use. You don't have to refrain using new yarn features because not everyone might use the same version. You can just focus on your infra and let yarn handle all the rest. Yarn is also able to prevent a project. Actually, it is able to prevent yarn install from ever working. If yarn install would modify the files within your project, then yarn will crash by using the -- frozen log file flag. And that's useful because on CI, you don't really want your yarn.log file to change because it means that the developer hasn't properly modified the log file. So by using this flag on CI, you can correctly prevent the log file to be out of sync with the package.json, which is super useful. So as a quick cheat sheet of what the feature that we've discussed, we have the workspaces that allow you to split your code into various pieces. We have the offline mirror that allows you to stop depending on the network. We have yarn policies set version that allows you to check in the yarn version that you use inside your repository so that you can guarantee that everyone is using the same version no matter what. We have yarn -- pnp that removes the non-modules and makes it much faster to run yarn install. And we have yarn -- frozen log file that prevents yarn from proceeding without error if the yarn.log file is out of sync with your project. So most of those features are really useful for CI because as part of the validation, they can catch a lot of errors before they even become a problem. Now, we are going to discuss a bit about the future of yarn, and in particular, one feature that is called zero install. Zero install is not exactly a feature. So the idea is that running yarn install is a problem. Yeah, I'm a yarn maintainer, but I'll tell you that yarn install is a problem. So why do I say that? The thing is that we do our best to write a software that is stable, but we are humans, and by time to time we make bugs. So one version of yarn might introduce a bug that doesn't exist in the previous version, or we might add a feature and it might have effects. Or it might be your system that is wrong. In one case, a few of the virtual machines that we were using became read-only, which means that we couldn't actually run yarn install on those machines, and it wasn't a great experience because everything crashed. And when everything crashed, it's not great to debug it. Or the install is, in general, much slower than you would like it to be. Even with PnP, we still need to do various things when you run yarn install, and that's still a bit too slow. So how could we find a way in order to not have to run yarn install so that our project is always in the right state? So as I said, it's a concept more than a feature in that there are multiple features in yarn that allow us to reach this ideal. It's more for applications. You will see why in a few seconds. And it's a bit less useful for libraries. But the goal is that we will never have to run yarn install again. We will only have to run yarn add and yarn remove. So how it works? Just add the yarn files to your repository. Yeah, I know what you might be thinking. I don't want to add the non-modules to my repository because it contains 20,000 files and that will kill Git. And that's right. Except that with PnP, we don't have non-modules anymore, right? With yarn, we now have exactly one file for each package. It's an archive, so it's a zip archive. So when you run yarn install, yarn will install all your packages, that you can check in within your Git repository, and it will work, because Git is OK with this amount of data. And the good thing with that is that if you have all your Yawn cache and your .pnp.js file within your repository, you have everything you need in order to run your applications. If you check out a different branch, it will still work because your project will be in the right state. You won't have to run yarn install. If you deploy on CI, you won't have to run yarn install either because everything will be correctly already installed. So that provides a lot of advantages. For one, it's a much better developer experience because you don't have to remember to run yarn install between each checkout, each pull, each rebase. You just have to make your regular workflow and let Yarn take care of the rest, and it just works. On top of this, it's much better from a peer standpoint, because now you have a clear view of which packages are added by a specific pull request. You can't miss that this pull request will add 3 megs to your repository, because now it's part of the peer. It also leads to faster, simpler, and more stable deployments, because we don't have to run yarn at all. One of the things I learned is that if a code is running, a code will fail. And in this case, if yarn install runs, in some cases it will fail. But if we don't have to run it on CI, if we don't have to run it on production server, then it means that we can deploy in all with the full confidence that everything will work exactly the same way in prod as it does in development. So here we have a small example of how it works. So here we have a package that contains Webpack 3. And if I make a yarn node, I get Webpack 3. And now I will try to upgrade it to Webpack 4, because 4 is better than 3. So I create a new branch, and I run yarn add, which downloads the new dependencies and store them somewhere. We will see where in a few seconds. And now if I make yarn node again, you will see that we have Webpack 4. So everything worked great. Now let's make a git status. And here you might see that we have a bunch of zip archives. Those are the archives that I mentioned. We just have to add them all to a single commit. And starting from there, we will be able to switch from one branch to another, and everything will just work. So for example, let's say that we have a product manager that is coming to you and tell you, we have this huge bug on the Webpack 3 branch, and we need to fix it now. Typically, you would have to switch back to Webpack 3, run yarn install, wait for it to complete, make your change, go back to Webpack 4, make your run yarn install again, etc. But no, here, you don't have to do this. You just have to check out the right branch, make your change. Everything works with Webpack 3. Check out again Webpack 4, and it works. And it's a much better experience when the context switching is 0, because then you can do much more context switching. You can work on more features at the same time. You don't have to be blocked by your tool. You can even merge Webpack 4 inside Webpack 3 into a different branch, and everything will work, because it's just Git. It's just merging files around, and it knows how to do it. Here we can see a more complex workflow. So I'm taking the Yarn 2 repository, which is called Berry, which is the code name of Yarn 2. And yeah, I'm cloning it locally. We actually use zip loading for our repository. And you will see why in a few seconds. It might seem a bit slower to clone the repository than usual, and it's true. But it's still much faster than if you had to run git clone and then run yarn install. So it balances out. So now we have cloned the repository. And what do? Well, we can do everything we want. We can run the unit test, and everything will work. Just runs. I didn't have to run yarn install, because everything is part of this repository state. And that's the kind of experience that we want to provide, so that you don't have to care about the state of your project, because everything is always consistent. This feature is completely optional. You don't have to use it. It's one more tool in your that is at your disposition. You can use it. You can not use it. You can decide to put the cache inside a shared directory between all your projects, as was the case with Yarn 1. It's just that now it's easier than ever to have this kind of workflow. So for libraries, for example, you typically might not want to do this, since if you just have a small library that it contains a single JavaScript file, then maybe it's a bit overkill to add the dependencies to the Git repository. So for those ones, you might disable easily the feature. But for real application that you will use in production, I think it's a very interesting approach, because then it will provide you a much better stability. And stability at the cost of size, I think it's OK. Yawn 2 doesn't come only with zip loading and zero install. It also comes with other features. So we will go quickly over a few others of them. We have an improved logging. So you might remember that Yawn prints emojis. And we like this friendly approach of printing messages. So now we are trying to go a bit further. And we are now using colors to highlight the part of the messages that have changed. The idea is that we want to decrease the cognitive load of communicating with a tool, so that when you see a Yawn message, you can understand what happens and why this message matters. For the same reason, every message, or almost every message in Yawn now has a message code. The idea is that those message code can be looked on Google, and you will reach the documentation of Yawn, which will tell you more detail about the message, and more importantly, in the case of warnings and errors, how to fix them. So we really want to make it so that you can fix the problem without necessarily having to ask us how to do it, so that you can have all the tools, and honestly, it's a bit less work for us, which is win-win for everyone. We will add new commands. One of them is Yawn DLX. If you know npx from the npm project, is very similar. The idea is that when you run Yawn DLX, the name of a package, Yawn will download this package inside the global store, so not in your project, and run it locally. The idea is that it allows you to run CLI tools without having to add them to your project, which might be useful if you're in the process of trying a new tool. So for a quick demonstration, we will use Terser, which is a minifure, a bit like a Glyphide.js. So here I have this Webpack configuration file, and I will want to minify it for some reason. Usually, I would have to run yarn add Terser, run Terser on the file, and then run yarn remove in order to remove the file, to remove the dependency. But now with DLX, I can just run yarn DLX Terser index.js, yarn downloads Terser, runs it, and that's it. And it didn't modify your package.json. What's great is that Yawn DLX uses plug and play, which means that we don't have to copy the files around when running an install, which means that the second time we will run Yawn DLX, it will be much faster, because then we will not have to copy the files. So here, yeah, it was less than a second in order to set up the environment for DLX, even though we still made the resolution to NPM to find out whether some packages had changed. So it's super fast. We don't only add new commands, we also improve the existing ones. So for example, we now have yarn up, which is a bit like yarn upgrade. The main difference is that it is able to upgrade a package inside all of the workspaces at once. So let's say that you have multiple workspaces, like front-end and back-end, and you want to upgrade the version of Lodash that they use. It's a bit annoying right now, because you have to go inside your front-end and run yarn add Lodash, and then you have to do the same thing inside your back-end. But now, with yarn up, which is completely aware of your workspaces, you just have to run yarn up Lodash, and Yarn will automatically figure out all the places where Lodash must be updated. We have Yarn link, which is now properly able to resolve peer dependencies. So if you make a link to a different project from your computer that has peer dependencies, it will work as you would expect. And we have a new feature, which is the interactive mode. The idea is that multiple commands, among them yarn add and yarn up, allow you to give instruction to Yarn as to how use what behavior to adopt. So it's super useful, because sometimes there are a lot of different options that Yarn can choose in order to do what you ask. But there is one of them that is better than the other. So for example, let's say that we have Yawn add. When you run Yawn add on a package, maybe you want to use the latest version from the npm registry. But maybe you want to use the same version as one of your other workspaces. Or maybe you want to use something completely different. So when you add the -- interactive flag to Yawn add, Yawn will now offer you a few options among those that are likely to be the one that you want. And that's super useful, mainly for the feature that allows you to reuse the same packages as your other workspaces. We have a new feature that is called constraints. The idea is, wouldn't it be nice if we had a way to run ESLint on our package.json, on our project, to ensure that all of our workspaces are satisfying some set of rules. Constraints allow us to do exactly that. They allow you to define your rules to make sure that your workspaces are following a set of predicates. And the great thing with them is that they are auto-fixable, and there is very few boilerplate. In order to reach this small amount of boilerplate, we use a different language than JavaScript, which might be a bit surprising. We are using Prolog. And the reason we are doing that is that Prolog is a declarative language in this situation. And declarative languages are uniquely suited for validation purpose, because you just have to declare what doesn't work, and Prolog do the rest. It makes the inferences for us. So for example, constraints can do this kind of stuff. They can prevent a package from being used by any workspaces in your project. They can force your project to use your workspaces to use a specific version of a dependency. They can enforce specific fields, for example, to ensure that all of your workspaces are using the private true field. They can prevent dependency mismatch across workspaces, and they can do much more. So actually, we are going to see a bit how it works in practice for the prevent dependency mismatch one. We have a small project that contains two workspaces, front-end and back-end. They both depend on Lodash, but they depend on conflicting version of Lodash. One is on 4.17 and the other is on 4.15. And that's not great, so we would like to use the same one for both. Additionally, those projects are actually TypeScript, so they should depend on the tslib package, but they don't. So we run yarn constraints check in order to figure out what are all the problems in our project, and I wrote a few rules that allow us to check just that. So in this case, you can see that Yann has been able to tell us that the backend and the frontend should depend on tslib, and that they are depending on conflicting versions of Lodash. With the yarn constraints fix command, Yarn will try to auto-fix all the problems it sees. So for example, in this case, it has automatically added tslib to all your workspaces because the rule told him that it should be like this. It hasn't been able to auto-fix backend and frontend in order to fix the mismatch between Lodash because it doesn't know which version to use. It doesn't know whether it should use 4.17 or 4.15. So there's an ambiguity that needs to be resolved manually, but in general, it is able to auto-fix a lot of things. When this kind of ambiguity happens, there's something that we can use, like the interactive mode. So we can just use yarn add lodash-i, and we enter the interactive mode. And here, Yarn is able to tell us that we have Lodash from latest, which is 17.11, or we can reuse one of the versions from our workspaces. And in this situation, we just have to pick the right version that we want to use, and everything will work. So in this case, we just want to use the highest one that is already used in our project, and Yarn install it. And it doesn't need to fetch anything because it's already in the cache, so everything just works. Constraints are very powerful, but we can do much more with them because they are powerful. In this case, we can see that there is a new command, which is yarn constraints query. And by using yarn constraints query, you can effectively ask Yarn to tell you all that he knows about your project. So you can tell him, OK, please tell me in this situation what are all the dependencies in all the fields for all the workspaces of my project. And it will tell you everything. Or you can refine the query and say that you already know some of the fields. So for example, in this case, I can tell him that I just care about the Lodash package. And Yann will tell you, will filter the results based on that. Since the query is Prolog, you can actually make pretty complicated query, but even simplest one are very useful. So to recap a bit, we have improved logging, we have new commands, we have improved commands, we have package constraints, we have zero install, of course, and we have a lot of other features that are too much to discuss in this talk. We actually have full changelog that contains much more information about the thing that changed, about the thing that are added, removed inside Yawn 2. So we want Yawn to be the foundation for your infrastructure so that you can rely on it and use it in order to build the rest of your infra, in order to specify your Webpack configuration, your JS configuration, this kind of stuff, so that you don't have to care about all the part that is dependency management. Yawn is an open source project, and we always want to get new contributors. We are actually spending a lot of time in order to do that. So for example, the code base moved to TypeScript in order to make it more familiar to you. The new design makes Yawn much more modular itself. So in fact, all of the features that I mentioned here are actually implemented within plugins. There are built-in plugins. So when you download Yawn, you already have all of them. But Yawn supports dynamically linking new plugins. So our idea with this is that you will be able to develop your own features without having to merge them into the core. So if you want to have a workflow that is adapted to your company, you can do this by writing a plugin that is unique to your company. It will be possible. Yawn is a very commonly used project, as we saw when you raised hands. So it would be very impactful for you to work on it. And we are very approachable on Discord. So if you want to try to contribute to an open source project in any capacity, it might be code, it might be documentation, it might be making events, we would be glad to hear about you. And we also have cool t-shirts for people who make significant contributions, which is a good thing, I think, for a lot of you. We actually have unisex and woman size t-shirts. So, ladies.